Welcome back, everybody. In this question, we're given that f of x is equal to the absolute value of x plus 3, and we have to write equations for each of these three expressions, and then we have to state the range of each new function. So starting off here, negative f of x, well, we know f of x is absolute value x plus 3, so negative f of x, we would just put in brackets the absolute value of x plus 3 for f of x. So this f of x is in like square brackets. So this here is in like square brackets as well. So basically it's like the a value is negative 1. And if we want to show this nicer, we could get rid of the square brackets. It's just negative absolute value x plus 3. So the a value is just negative 1. So basically what we did was we took this function and we reflected it in the x-axis because that a value is negative 1. It's not vertically stretched or compressed because it's a 1, but because it's negative, it's been reflected. So the answer here is negative absolute value x plus 3. And for the range, what we can do is we can draw out this parent function. So absolute value x plus 3, that's like taking the absolute value of x and shifting it 3 to the left. So that new vertex is going to be a negative 3 and 0. So what's this going to do? Well, we're taking this parent function and now we are reflecting it in the x-axis. So it's going to be going this way, right? So what's the range of this function here going to be? Well, notice all the y values are less than or equal to 0. So basically, y is less than or equal to 0. Right? Moving on to the next one. We have f of negative x. So basically, if f of x is equal to the absolute value of x plus 3, then whatever we sub in for x here, we're just going to be subbing in for x there. So like f of 5, for example, would be absolute value of 5 plus 3. Or f of a would be absolute value of a plus 3. Right? So whatever's here, we're just subbing in for x. So that means that f of negative x is just going to be the absolute value of negative x plus 3. So that's going to be the answer here. It's going to just be negative x plus 3, or 3 minus x. And if you want to actually write this in a nicer way, you can also write it like this. So you could factor out that negative and you could write x minus 3. Because that negative 1 is like the k value, right? And the k value can't be attached to the x. But either way works. What this is doing is it's just reflecting the function in the y-axis. So if we draw out the parent function again, so this is negative 3 and 0. So this is f of x, right? Well, what are we doing here? We're taking f of x and we are reflecting it in the y-axis. So now the function is going to be here at positive 3 and 0. That's how this function is going to look like. And if you wanted to take it and you want to map it, so here, notice that the a value is 1, positive 1. The k value is negative 1. The d value is 3. And then the c value is like 0. You could take the absolute value of x, put it through mapping, and you would end up with that graph right there. Okay, so the range for this graph is basically YER, and y has to be greater than or equal to 0, because now it's pointing up. Okay, and then negative f of negative x, we are basically just combining both transformations from both of these. So we got the negative f of x, then we got the f of negative x. So they're combined in one. So basically negative f of negative x, the negative would go in front of the absolute value, and then we would sub in negative x for the x in the absolute value function. So that's what the answer here would be. So it would be negative absolute value of negative x plus 3. And it's basically the same thing. So we're taking that parent function, which is at negative 3 and 0. We are reflecting it in the y-axis first because that k value is negative 1. So that's going to be here. So that would be at positive 3 and 0. And then the a value is negative, so we're reflecting it in the x-axis. So that's going to be going down like that. Okay, so this is f of x. This function here is f of negative x. And then this function here is negative f of negative x, like that. All right, so the range for this new function is y is less than or equal to 0. Right, so there's multiple ways to do it. You can use this as the parent function, and then you can just transform it with an a value of negative 1, a k value of negative 1, and here an a value of negative 1 and a k value of negative 1. Or you can treat, like we've been doing, the parent function as absolute value x, and then you could just run it through all the transformations. So here we would have to rewrite this as negative x minus 3. All right, so the a value would be negative 1, the k value would be negative 1, the d value would be 3, the c value would be 0. And then we could take this and transform it through all these values. And then we would end up with this graph. So either way works. You could treat this as the parent function, or you could treat this as the parent function and just go right from the base function and do all the transformations. But I think it's just easier to treat this as the parent function because then one of the transformations is already taken care of. That shift to the left of 3 is already taken care of. But either way, these are the answers that you should get in the table.